Hello students, welcome to Educate. Today we are going to start with chapter 8 of physics. We will do numericals on it. We have already done the chapter. So till question 8.2 we have done, and we are going to start from question number 8.3. Here we need which material has greater Young's modulus, which of the two is a stronger material. So strength is generally determined by formula stress upon strain. What does it give? It gives Young's modulus. So we have to check in the two cases the slope. If slope is more, Young modulus will be more. So although scale is not given, but you can guess in which case the stress and strain graph is more slopy. That is, in this case, you can say that B will have more slope and hence it will have greater Young's modulus. And as far as the strength is concerned, so that will be material A. Now, next question is, read the following two statements below carefully and state with the reason if it is true or false. Young modulus of rubber is greater than that of steel. So for this purpose, we have to see a proof. We have to prove that Ys is greater than Yr. So for this purpose, we apply formula by steel equal to force upon area, and say delta L steel, and this is L. Situation is like this: for steel and rubber, same length is taken, and elongation delta L steel and delta L rubber, force applied is same, area of cross section is same, and in common experience you must have seen that delta L rubber means you can, if you apply force, you can stretch more to the rubber than the steel wire. So obviously this is clear. Now Y steel divided by this, right, Y rubber. So here put the values. F into L will remain same, A will remain same, only delta L rubber will be different. So other things will cancel out, F, L, A, E. You will be left with delta L rubber divided by delta L steel. And as you know, here numerator is larger, so you can say it is greater than 1. So you have got Ys upon Yr is greater than 1, which gives Ys is greater than Yr. So this was to be proved. This is one of the good question. The stretching of a coil is determined by its shear modulus. Of course, if you consider a coil, what happens? If you stretch it, what will happen? Will there be change in the length of the total wire? No. But its shape will change. So that is why we say that stretching of a coil is determined by its shear modulus. Had it been a case of straight wire, and if you would have applied here force and there would be an elongation, then it could be the Young's modulus. But here, since it is a coil, so if you stretch it, then it will get deformed, or you can say there will be extension, but whole length of wire making the coil will remain intact. So that is why this is correct one. Now, next question is, two wires of diameter 0.25 centimeter, one made of steel and the other made of brass, are loaded as shown in the figure. The unloaded length of steel wire is 1.5 meter and that of brass wire is 1 meter. Compute the elongation of the steel and the brass wires. So here The situation is like this. Situation is shown. So we consider first steel. So what is happening with the steel wire? Length is given 1.5 meter. Total weight, this and this will add up. So it will be 10 kg. So just write F 10 into, let's take G as 9.8. So this is total weight. And here we also need Young's modulus of steel. So it is 2 into 10 to the power 11 Pascal. So Y steel 2 into 10 to the power 11 Pascal. Now we have to find out delta L. So we can evaluate. Apply the formula. Y steel equal to F upon A times delta L into L. So we can do one thing. We can write delta L here. This will be F into L divided by A into Y steel. Let's put the values. So delta L equals force. That is will be 98 multiplied by length of the wire, that is 1.5, whole divided by area of cross section. Here diameter is given. So area of cross section can be evaluated pi into r square. So 0.125, just half of it, into 10 to the power minus 2, because it is in centimeter square. So this value you can put. So you can say pi times 0.125 into 10 power minus 2 whole pi r square into Young modulus of steel, that is 2 into 10 to the power 11. Now what is to be done? We simplify it. Delta L equal to 98 into 1.5 into, here we can simplify 1.5 divided by pi, let's write 3.14 into, here if you convert it into power, so 1.25 if we write, or if we write it as 125, in that case what do we get? 3 negative power will increase, so this will become 10 power minus 5. So 125 into 125 into 10 to the power, did you understand or not? Here we have 0.125 into 10 power minus 2 whole square. So we can write it 125 into 10 to the power minus 5 and then whole square. So 125 into 125 into 10 power minus 10, right? So that I am doing here. So this will become into 10 power minus 10 into 2 into 10 power 11. Now from here only 10 will be left. So question will become little simpler. So we can do one thing here. We can write it as delta L equal to 98 into 1.5 divided by 3.14 into 125 into 125 into 10. Now we can simplify it. So its answer would be, you can take time to evaluate it. So it will be 1.5 into 10 to the power minus 4 meter almost. So you can do calculation. I think you have understood. Now we can take second part. For second part, here only this portion should be considered. So this 4 kg will not be considered, only this portion. So you can say for brass, here F will be just 6 into 9.8 Newton. L is given as 1 meter. Delta L is to be found. And young modulus of brass is how much? In question it's not given, you have to consult the table. So let's see what it is. It is 9.1 into 10 to the power 10. So this is information. And area of cross section as previous one, area will be pi into radius 0.125 into 10 to the power minus 2 whole square, or pi into 125 into 10 to the power minus 5 whole square, or pi into 125 into 125 into 10 to the power minus 10. So this value you can make use. Further simplification is also possible. Formula is y equal to f L divided by A into delta L, and your concern is to get delta L for this. So delta L will be equal to F into L divided by A into Y. We can put the values. So F is 6 into 9.8 into length of wire is given as 1 divided by area of cross section is pi into 125 into 125 into 10 power minus 10 times value of Young's modulus, that will be 9.1 into 10 to the power plus 10. We can again simplify. Here these two terms will cancel out. Now it's not tough. 6 into 9.8, if we write pi as 22 by 7, so 7 will come over here. This will be 22 into 125 into 125 into 9.1. You can use calculator to calculate it, and it will be, just take 1 minute to evaluate. So 1.3 into 10 to the power minus 4 meter. 1.3 into 10 to the power minus 4 meter. So this is the question. Now we are going to check next question. Next question says the edge of an aluminum cube is 10 centimeter long. One face of the cube is firmly fixed to a vertical wall. A mass of 100 kg is then attached to the opposite face of the cube. The shear modulus of aluminum is 25 GPa. What is vertical deflection? So delta X is to be found. So formula for shear modulus will be. So here situation we can discuss. So shear modulus, suppose we denote it as G. It can be written in terms of theta, eta also. So G equal to F upon A times, here suppose deflection is X and original length is L. Here we can write delta L also, so it does not matter. So here in our question they are asking that you have to find out vertical deflection. It means you have to evaluate X. So X equal to F into L divided by A into G. Up to here there is no problem. And as far as area is concerned, so from here this is cube, so area will be equal to length into breadth here, so 10 cm, so 100 cm square, or 100 into 10 to the power minus 4 meter square. Did you understand? 10 cm means 10 into 10 power minus 2 meter. If you square it, so you will get this much. So you have got the area, every information you have. So let's write it, x equal to f. So f in our question is 100 kg times, so just write 100 into, either you write 9.8 or just 10, it depends on you. And length is same, age of aluminum length is 10 cm, so 0.1 divided by area of cross section, that is not cross section, area just here of that face, 100 into 10 to the power minus 4, and then G, value of G is 25 giga, 10 power 9. Now what R is left? So here, if we remove 100 from here, these two decimal can be removed, so it will become 98. And here it is 100. So from here, what power? So 2 power will be reduced. So just write here 25. And then what more? 25 into 10 to the power. Total power is 9 minus 4 plus 2. So 11, 7. So 98 divided by 25 into 10 to the power minus 10 to the power plus 7. So it will be very small value. Let's see what it comes. You can evaluate it, and if confusion comes, I will redo it. So here almost 4 times 4 into 10 to the power minus 7, 3.98 something. So answer is this. Even if it is very small, I don't think that anything is wrong. Yeah, so it's correct. Okay, next question is, 4 identical hollow cylindrical columns of mild steel support a big structure of mass 50,000 kg. So if there are 4 structures, they are supporting 50,000 kg. So for one structure, calculation can be done, and from where we can calculate compressional strain. So force, you can say 1 by 4 of 50,000 multiplied by, say, 10. The value of G, I'm taking 10. So it will become 125 followed by 1, 2, 3 zeros. It's a Newton. Is it okay? Because 125 0 up to here, and then 10 is being multiplied. Inner and outer radii of each column are given. So here R1 is given as 0.3 meter, outer radii is given as how much? It's 0.6 meter. Then area, if we find, so pi R2 square minus R1 square, right? So 22 by 7 R2 square, that is 0.6 square minus 0.3 square, 3.14 into here a square minus b square can be applied. So 0.9 multiplied by a minus b and a plus b. A plus b 0.9, a minus b will be 0.3. So either you write 3.14 into 9 into 3 into 10 to the power 1 2 with the negative sign meter square. So this is area. You have got the value. So let's write this value here. Area equal to, if you want to write this also in power, so make it 314 into 27 into 10 to the power here 2 more negative, so 10 power minus 4 meter square. So you have information of F and A. What more you need? Compressional strain. Strain means delta L upon L you have to find out. But for this purpose, you have to write the value of Young's modulus. So known value of Young's modulus for steel, Y steel is 2 into 10 to the power 11, unless it is given some other value is given somewhere else. So accepted value in the table, it is Y steel is 2 into 10 to the power 11 Pascal, right? So these are the values we have to find out. Compressional strain, it means we have to find out delta L upon L. So let's evaluate. So Y steel, or just write Y, not needed because comparison is not to be done. So Y equal to F upon A times delta L upon L. So this value we can take to LHS because we have to find out delta L upon L. So delta L upon L will give how much? F upon A times Y. Let's put the values. So F is 125000, right? Then A is 314 into 27 into 10 to the power minus 4, right? Into Young's modulus 2 into 10 to the power 11. Now these two will become, let's further simplify. So delta L upon L will become 125 divided by, I will take 3 0 to cancel to make it 10 power 8. So that will be easier. 10 power 8, and then with this it will cancel out. So 10 power 4 will be left. So 10 power minus 4. So this gets cancelled, this gets cancelled, this gets cancelled into 10 to the power minus 4. Now 314 multiplied by 27 to the 54. Let's simplify. Take 1 minute to evaluate it. It will come out to be 2.8 into 10 to the power minus 6. Is it correct? Yes. So is it okay? Yes, you can just evaluate. Why do I say is it correct? It means you should also evaluate. Sometimes mistake may occur even by teachers. So be careful. Now, next question is, a piece of copper having a rectangular cross section of this much is pulled in tension with this much, producing only elastic deformation. Calculate the resulting strain. So question has information. Area you can find, it is 15.2 multiplied by 19.1 into 10 to the power minus, see, millimeter into millimeters, so millimeter square 10 power minus 6 meter square. This is area. Pulled with the tension, it means force is given as 44500. Alright, producing only elastic deformation. Calculate the resulting strain. So strain means delta L upon L is question mark. But in order to get this, we need Young modulus of copper, YCU. So its value can be seen from table. Let's see what it is. So let's see what is given in the table. So you have to search it in the table. I don't have value right now. So either give me 1 minute. Let me find out Young modulus of it is 1.3 into 10 to the power 11. So 1.3 into 10 to the power 11. Yeah. Now you can proceed. So Young modulus is given by force upon area times delta L upon L. Is it correct? No, it's not correct. Correct is delta L upon L. Correct? Now, what is our concern? We have to find out delta L upon L. The same thing is to be done. Just write it as delta L upon L equals F upon Y into A. Let's put the values. Delta L upon L is F. F is this much, 44500. F upon Y. Y is 1.3 into 10 power 11 into Y into A. Area is this much, 15.2 into 19.1 into 10 to the power minus 6. Now simplify. So here so delta L upon L equal to 44500, and here this is 11 power and this is 6 power, right? So 10 power 5 positive will be left here. So let's write it here, 10 power minus 5. Then in denominator, what is left? 1.3 into 15.2 into 19.1. Let's take these, remove these decimals from here also. So 44500 divided by 13 into 152 into 191 into 10 to the power minus 5. From here 1, 2, 3. 3 positive power. Right. So 44500 into 2 negative powers are left. So 2 negative powers are left means what? You can cancel these two zeros. Divided by 13 into 152 into 191. Just evaluate it. Take 1 minute to get the answer. $1.27 into 10 to the power minus 3 almost. Calculate it and check. Now let's go to next question. Question number 8.9. A steel cable with a radius of 1.5 centimeters supports a chair lift at a sky area. If the maximum stretch is not to exceed this much, what is the maximum load the cable can support? So stress is given by force upon area, right? And in this question, with a radius of this much is given. So if a radius is given, it means area can be found 1.5 into 10 power minus 2. So area will be pi r square, that is 3.14 into 1.5 into 10 to the power minus 2 whole square. So 3.14 into 2.25 into 10 to the power minus 4 meter square. So this is the area. Now we need here what is maximum load. It means let's find out force, then we can convert it into mass by dividing by 9.8. So that we can do later, but first is force equal to stress into area. So in our question we are given stress and area. Stress is given as 10 power 8. So just write 10 power 8, and area is this much, 3.14 into 2.25 into 10 to the power minus 4. So this will be in Newton, right? Power you can adjust 3.14 into 2.25 into 10 to the power 4. This is force. So weight is same as power. So if we need mass m, so force divided by 9.8. So 3.14 into 2.25 into 10 power 4 divided by 9.8 kg. Take 2 minutes and try to get the answer. So what is mass? You can evaluate. You can also leave it in terms of force. Now, next question is, a rigid bar of mass 15 kg is supported symmetrically by 3 wires, each 2 meter long. Those at each end are of copper and the middle one is of iron. Determine the ratio of their diameters if each is to have the same tension. You can understand the question. Question is simple. So what can you do? How to solve it? You have read the question. Question says, I can reread. A rigid bar of mass 15 kg is supported symmetrically by 3 wires, each 2 meter long. Those at each end are of copper and the middle one is of iron. Determine the ratio of their diameters if each is to have the same tension. So what happens here? Load will be same or not? So as per question, the information given is tension in each wire is, suppose we can use the tension in each wire is T, then we can write the formula. So what is formula? Formula, same formula as you have studied, y equal to F upon A delta L upon L. Right. So here, since all three wires are supporting the weight and they will have equal stress, so we can say that force means tension will be same, length will be same, delta L will be same. So what is left? So we are left with, sorry, y. Here if we are taking other things constant, these three things as constant, then we can say a constant times A, or y is inversely proportional to area. We have to compare the diameters, right? So here we can further write y proportional to 1 upon area is pi times d square by 4, correct? Because pi r square, r is d by 2. Or if we further write, we can write the d square proportional to 1 upon y, or d proportional to 1 upon root y. So we have got this relation. And now in our question, if Young modulus of copper, here material is what? One is copper and middle one is iron. So now we can write this. Suppose we write d copper divided by d iron, then what happens? It will be equal to root of y iron divided by y copper. If from table you observe the values of y copper and y iron, put those values. So y iron is around 1.9 into 10 to the power 11, and for copper it is 1.1 into 10 to the power 11. So if we simplify, root 19 by 11 will be left. Further, you can find its square root. First divide it, then find square root, and then you can evaluate. I think you can do it. So this is all for this lecture. We will continue other questions in next lecture. Thank you, Team Educate.